Have you ever just stared at your cloud bill and thought, okay, exactly how much of this is literally just dead weight? For IT operations, cloud architects, and database pros, this is kind of the universal pain point, right? I mean, we collect logs because, well, we have to. But eventually, this blind data hoarding just mutates into ballooning cloud costs. If you're paying to store massive amounts of log data that you're never, ever going to actually use to troubleshoot or run analytics, it is definitely time to rethink your strategy. So welcome to this explainer. Today we're doing a deep dive into OCI logging analytics cost optimization, pulling from some really excellent source material. We're going to look at how to transform your operations from passive data hoarding into strategic data curation over an Oracle Cloud infrastructure. By the end of our time together, you'll know exactly how the documentation recommends managing your log data lifecycle to squeeze the absolute most value out of your OCI budget. All right, let's dive into this. Quick roadmap for our journey today. We'll hit the cloud cost challenge, look at OCI storage mechanics, talk about categorizing log data, go over best practices, and finish up with monitoring and alerts. All right, kicking things off with Section 1, the Cloud Cost Challenge, Balancing Efficiency. Look, logs are literally the lifeblood of our infrastructure. They drive our informed decision-making, our security audits, our performance tuning, the whole shebang. But storing them incorrectly or holding on to everything indefinitely, that drains budgets incredibly fast. Efficient management of cloud cost isn't just about, being cheap and cutting corners. It's a genuinely pivotal aspect of your operational success. You've got to strike this really delicate balance between cost, performance, and compliance. And to do that, we absolutely must understand our data's lifecycle and set some very precise retention policies. Moving right along to Section 2, OCI storage mechanics, understanding the rules. Okay, 300. I really want you to anchor your mental model right here with this specific number. In OCI logging analytics, the pricing model is based entirely on the size of the ingested and processed log data. And the golden rule here is that one active storage unit, or one archive storage unit, equals exactly 300 gigabytes of log data. That is the fundamental building block of your billing. Now, let's contrast the two storage tiers, active storage versus archive storage. Your active storage is charged based on a monthly list price, even though it's metered hourly per unit. Archive storage, on the other hand, is purely an hourly charge, which obviously gives you some massive cost reductions. But here is the catch, and it's a big one. Archive storage only becomes an option when you have at least 1 terabyte of log data already sitting in active storage. Plus, OCI charges you for a full storage unit the second your data spills over into the next block. So if you hit 301 gigabytes, yep, you are paying for 2 units. Understanding the actual timelines of archiving is just as crucial. Log data becomes eligible to be moved to archive storage when its newest timestamp is older than 30 days. And here's a little technical gotcha you really need to remember. The background archive process runs automatically every 24 hours. It literally doesn't matter what time of day you enabled the archive, it runs on its own rigid 24-hour cycle. Oh, and keep in mind, active log entries cannot be archived based on a query filter. No way. It is strictly based on age. Which brings us to Section 3, categorizing log data, sorting incoming sources. Let's be honest, not all logs are created equal. You might have audit logs tracking crucial security events. These fall under archival data and usually need to be retained for years for compliance reasons. Then you've got your service logs, like API gateway or VCN flow logs. This is operational data that you might keep for maybe a few weeks or months to track current network behavior. And finally, custom logs for app diagnostics are often just transient data. You might only need these for a couple of days to troubleshoot a live, active bug. Mapping your sources to these categories instantly tells you exactly what retention lifespan you should apply. All right, Section 4, Best Practices, Cost-Saving Strategies. Let's talk tactics. If there is just one quote you take away from this entire explainer, please let it be this. Not all logs need to be retained in active storage unit. It sounds so obvious, right? But it is arguably the most frequently ignored principle in cloud logging. The shorter your retention policies, the fewer storage costs you incur. It really is that simple. So the absolutely critical point here is establishing a purge retention policy. Think of this as a hard, defined rule that dictates exactly when log data is permanently deleted to drop your costs. Remember a minute ago when I said the archive storage unit doesn't allow selective archiving? If data hits 30 days old, it's getting archived automatically. Therefore, your absolute best defense here is combining an archival policy with a totally ruthless purge policy. The source material actually outlines this brilliant, highly actionable approach called the Day 29 VCN flow log tactic. Okay, let's say you set your active storage duration for 30 days. Now, you know VCN flow logs are incredibly bulky, they take up huge amounts of space, and honestly, they rarely provide any actual value for troubleshooting application issues weeks after the fact. So, here's the trick. You purge your VCN flow logs on day 29. By proactively deleting them one day before that automated 24-hour archive job kicks off, you completely prevent those massive useless logs from eating up your archive storage budget forever. Now, what about the logs you absolutely must keep for years, like audit data? For that, you should look way beyond a standard archive storage and leverage the Object Storage Archive tier. This gives you extreme cost savings because of its massive price advantage. But as always, there's an operational trade-off. This tier is only for very, very infrequent access. If you ever actually need to read those logs, it requires real restore time from the deep archive, and you literally have to manually upload the data back into logging analytics using an object collection role. So yeah, it's super cheap, but it's pretty slow to retrieve. Oh, and speaking of retrieving data, be super careful with this common trap. Recalling archive data into your active workspace using timestamp and query filters actually makes a copy of the log data inside your active storage. So temporarily, your storage footprint for those specific logs is literally doubled. To ensure this doesn't accidentally turn into a permanent billing nightmare, you've got to follow this exact sequence for cost-effective data recall. First, recall the data tightly using your timestamps and query filters. Second, do your root cause analysis. Third, and this is absolutely crucial, explicitly purge the recalled log data when you're done. And finally, release the log data to completely clean up that active recall. If you skip steps 3 and 4, you are going to be paying standard active storage rates for old, already analyzed data. No thanks. Wrapping up with Section 5, Monitoring and Alerts, Automating Defenses. To stay proactive, you need to monitor specific metrics in the OCI monitoring service. The exact metric namespace you want to track is OCI Logging Analytics. You'll want to watch active storage used, archival storage used, and processing errors. But pay attention to this key architectural detail from the source material, because logging analytics is a tendency-level service. These metrics only populate at the root compartment level. You definitely want to keep a really close eye on ingestion spikes before they become billing realities. The precise query parameters you need here are to use the log collection upload data size metric. Set your interval to 12 hours, or maybe 1 day over the past 7 days, and absolutely make sure you choose some as your statistic. Setting this up ensures you immediately spot if a rogue application suddenly decides to flood your system with gigabytes of useless diagnostic logs. For your day-to-day visualization, you actually have a couple of tracking methods. The more manual method is using the admin storage page, where you can literally use the purge logs feature to estimate your storage usage by inputting timestamps and queries without actually purging anything yet. Or a much, much better approach is leveraging pre-built dashboards. You can easily import the Security Operations dashboard directly from the Oracle Quick Start community repo, and that gives you instant, beautiful visual tracking of your entire logging footprint. Ultimately, though, you've got to automate your defenses. Please don't rely on humans checking dashboards. Set up alarms in the monitoring service to automatically trigger if storage usage spikes unexpectedly. Then tie that straight into the business side by setting budget alerts in OCI cost management. This ensures your team is notified well in advance if your observability and management compartment spending even begins to approach your monthly threshold limits. So, I'm going to leave you with this final, somewhat provocative thought. When was the very last time you actually audited your log retention policies? If your answer just now was never, or I really can't remember, it is highly likely you are bleeding cloud budget on data you literally do not need. Take the mechanics, take tactics like that Day 29 purge, use the automated guardrails we explored today, and go audit your OCI environment. Trust me, your cloud budget will thank you.